वो है नॉट गेट, या इसी गेट को आप इन्वर्टर भी कह सकते हो. So the NOT gate, by definition, a logic gate that produces high output if its input is low and produces low output if its input is high is called the NOT gate or inverter. The inverter performs the operation called the inversion or complementation. So if you have 1 at the input, it will give you a 0 at the output, and if you have 0 at the input, it will give you 1 at the output. The sample of this gate is like this: the triangle and a bubble on the top of the triangle, and here it is input and here it is output. For example, if you present the input by A and the output by X, then the output would be equal to X is equal to A complement, because it takes the input complement at the output. So this is the simple sample of the NOT gate. And you can also see this sample if bubble instead of on the top, if it is at the bottom side, at the input side, still it gives the same functionality. That this is also equivalent of this. And there are some also samples which sometimes they used inside the ICs, like this one, the square, and some this cut at the output. This is also the sample of the NOT gate. Or you can give this triangle cut at the input, that is also NOT gate. But what we would be using, just we would be using this sample or this sample, and those two samples maybe those would be given at the input or output of the ICs, but normally when we use then we use this type of sample. So I hope that it would be clear now. So now you can see this is our NOT gate, and the input is A, the output is X. So X is equal to A complement. So now if you take the input as low, that is 0, the output would be high. And if you take the input as high, the output would be low. So this is what? This is the NOT gate. Now, if you give this 0 and 1 if you take it like a wave, so those are the digital pulses. This lower part is called the 0, upper part is called the 1. So now at time interval t1, if you transit from 0 to 1, and if time interval t2, if you come from 1 to 0, then output would be very opposite. That is, at T1, you would be coming from upper to lower side, and T2, you would be going from 0 to 1, that is low to high. So this wave shape is opposite to this wave shape. So if I combine these two shapes, this is the input, this is the output. You can see the output is very opposite to that of the input. Opposite means complement of the input. So I hope the NOT gate is clear. जी बोलिए.
Clear, sir.
Okay, good. Thank you. I will move for the next one. Now, AND gate. I can define the AND gate as a logic gate that produces high output only if all of its inputs are high, or a logic gate that produces low output if any one or more inputs are low, is called AND gate. So in very simple, AND gate performs logical multiplication. So that is, if the inputs are A and B and whatever A and B, if there are three inputs, that would be A, B, and C, and the output is X, then X is equal to A multiplied by B multiplied by C. So, but the result of the multiplication will not be more than 1, because 1 multiplied by 1 multiplied by 1 is equal to 1, and 1 multiplied by 0 multiplied by 0 would be 0. If there is any one 0 at the input, the output would be 0, and if all inputs are high, the output would be high. So this is the truth table. The truth table gives all the possible inputs and outputs. So if you have two input AND gate, like this is the two input AND gate, If you have 0 0 at the input, the output would be 0. If you have 0 1, the output would be 0. So now you just multiply these two and you will get this one. 0 multiplied by 0 is equal to 0. 0 multiplied by 1 is equal to 0. 1 multiplied by 0 is equal to 0. 1 multiplied by 1 is equal to 1. So that's why we say that it performs the logical multiplication. So not necessary that you would be having the AND gate with two inputs. You can have AND gates with number of inputs. But how do you know that how many possible conditions would be there? If there are three inputs or there are four inputs, we can take help from this formula, that is n is equal to 2 power n. So n is the number of possible conditions at the input, and small n is the number of inputs. Suppose if you have two inputs, like of this case, the truth table is given over here. You can count 1, 2, 3, 4. Four possible conditions are there. So that is 2 power 2 is equal to 4. So the four combinations are over there. If you have three inputs AND gate, then how many outputs would be there? 2 power 3 is equal to 8. And similarly, if you have four inputs of any gate, of any gate, then you would be having total 16 combinations over there. And as many inputs you put, that you will put in the n, and the capital N will give you the number of possible conditions of the input. So now you understand this. So this is the sample of the AND gate, and you can also see this sample, but normally we use this sample of the AND gate. And the truth table, I just presented it over here like this. The 0 0 means that I will put 0 at one input and 0 at the other input, and the output is 0, means the output would be 0. 0 matlab low, and 1 means high. So similarly, 0 1 low high, output low. But in contrast, if there are two both inputs are high, then the output would be high. Is it clear?
Yes, sir.
Yes,
Good, thank you.
sir.
Yes, sir.
Okay, I'm coming for one of the practical example. If you want to use the AND gate, then how you can use, and how you can give the output. For example, I have some pulses at the input of AND gate at one input, and some pulses I have at the other input. So I am asked that what would be the output waveform. So if is one input waveform, this is the second input waveform, what would be the output waveform? From here you can see upper means 1, lower means 0. So 1, 1, the output would be, please reply me. If there is 1, 1 at the input, the output would be,
One.
I
good, 1 high. This is high. And if there is low, high, the output would be,
low,
this is low. If there is low, low, the output would be,
low,
if there is high, low, then the output would be,
low,
if there is high, high, that is 1, 1, the output would be
I.
I.
One.
high. Very good. Now you can see that how we can explain those waves, the input and the output. So similarly, you can explain these two as well. So this is the explanation of the um, AND gate. Now we come for the last 10 minutes. I will give you another code. So then I will take 5 minutes. So first I will complete my 10 minutes. Now I will come for the OR gate. So the OR gate sample is this one. This is one input, this is other input, and this is output. And uh, uh, basically the OR gate performs the logical operation of addition, but it would be that type of addition that you cannot move more than 1. It means that 1 plus 1 is equal to 1. It would not be 2. So anyhow, 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. But 0 plus 0 is equal to 0. But 1 plus 1 would also be 1. Like this. Anyhow, so how you can define the OR gate? A logic gate that produces high output if any one or more of its inputs are high, and produces low output if all inputs are low. So the low output would only be produced if all of its inputs are low. So this definition is for any number of inputs. This truth table is just for two inputs. So now you can see I also explained that it is the logical equivalent to the logical addition, that is x is equal to a plus b. So a is one input, b is another input, and x is output. So those two are the samples, and this is the truth table. Now you can answer me. 0 plus 0, that would be 0. 0 1, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1 logically. Otherwise 1 plus 1 in ordinary style it would be 2. Anyhow, so now this is uh, our gate. Now we come for one of the problem. Two wave shapes are given. One wave shape is coming to A, one wave shape is coming to B. Please switch on your mic who want to give answer. I would be asking you. Uh, if one input is high and other input is low, the output would be
high,
high.
I,
Very good.
I,
If both inputs are low, the output would be
low,
low.
low,
If one is low, the other is
low,
high, the output would be
high,
I,
high. Very good. So this is the OR logic gate. Now you are very clear about this thing. After OR, there is another gate, that is NAND gate. So NAND, in very simple, NAND is the complement of AND gate. Like you now you know that this is AND gate. If you attach an inverter, that is the NOT gate, at the output of the AND gate, that will become NAND gate. So that instead of making that complete inverter over there, we just make a bubble over there. So this is the sample of what? This is the sample of NAND gate. So now how can we define? Definitely it is different from, it is the complement of the AND gate. So how we can define it? A logic gate that produces high output if any one or more of inputs are low, and produces low output if all of inputs are high. So that these conditions are very opposite to that of the AND gate. So is the NAND is the complement of AND gate. So now you know that the AND gate is X